Hello everyone. Today I wanted to talk about agentic AI systems. And to reach there, I wanted to talk about a couple of things before I kind of explain the need of agentic AI and give a very high level idea of what it is. So what I'll cover is I'll first cover basic use of LLM. Then I'll explain what is a chain based flow. Then I'll get to control flow via LLM. And this whole big picture will kind of summarize what we want to do. Okay. And with all these 3 points, you'll see that what we are trying to do becomes more and more complicated as we go down. Okay. To start with, one of the easiest application of LLM is that you have an LLM and you feed in a prompt and it gives a response, right? And in general, what I would say is there's a start state, and then you have an LLM, and then you have an end state. So it's more like a single step LLM kind of an operation, which is the beginning of anything. So let's look at the code, a very simple code of how we can use an LLM as a black box. Of course, the intention of this video is not to explain you what are the internals of LLMs, what is a transformer, and things like that. The goal is to give you like a practical example of how to use it, what is the need, what is the situation, and what can we achieve with agentic AIs. Okay. So what I'm showing you here is basically what I've done beforehand is I've created this config.ini where I have all these API keys for different things. For example, I have API keys for Gemini, I have API keys for LangChain or Langsmith, and then I have some user agent name, I have OpenAI keys. Okay. So this is what I have. So I'll run this so that I have all the keys in the code. Then the next one is what we are doing is we are using GPT for all in LangChain. And then we also have a prompt template. So let's start with the template. In this case, the template is let's think step by step of a question. Based on all the thought, the final answer becomes. So this is the template. And we can create a prompt by using our prompt template and some input variables, which was in this case, it was a usual string, right? Where question is the variable. So we have this input variable, which is the question. So this is my prompt. Then I have actually, what I've done is I've downloaded Llama 3.8 billion model, right? So I have it in my local path. You can see this path. And I'm using a gguf file, so I just downloaded it from Hugging Face. Anyways, you should be able to download a gguf file from any location where it's available, but Hugging Face is a good place to search for it. Then I can create my LLM by saying GPT for all. I provide my model path, then I provide my device, which is GPU. So right now what I'm using is 12 GB NVIDIA graphics card, and this model is able to run on it easily. Then I create my chain, which is I create a prompt followed by the LLM which I've chosen. So this is my LLM chain, which is kind of a one-step thing, right? I have a prompt, then I have an LLM, it will give me a response. So once I have an LLM chain, I can invoke this chain by saying LLM chain.invoke, and then I provide the question. And if you remember, prompt had a variable called question. So that's why in my JSON, I show that the key is a question, which exactly matches this question in the prompt. And then I ask who is the CEO of Google and why he became the CEO of Google. Okay. And you'll see that it gives like a long response. I'll just copy it and show it to you. So this is what it gives me, right? So obviously the answer is correct, which is Sundar Pichai, and it gives you a lot of detail and what he has done at Google for many, many years. And he also tells like the previous guy was Larry Page and things like that. So it gives you a lot of information. I'll do the same exercise, the same prompt. It is just the model I've changed. I've changed it to Llama 3.2 1 billion model. Again, I've downloaded GGUF file from Hugging Face website. and I have it in this location in my computer. Again, I create my LLM using GPT for all, and then I give the model path, and I provide a device which is GPU in this case again, my 12 GB GPU, which is actually pretty small by the way. By today's standards, it's a bare minimum you should have. So what I've done is like I had like a cost budget. So with that budget, I like got a custom built PC which has like a Ryzen 9 processor, 64 GB RAM, couple of terabytes of hard disk, and 12 GB of GPU. And this is like a bare minimum, I feel, if you want to build a PC. And if I wanted like anything more than that, maybe I can upgrade to 24 GB graphics card, but that would be my upper limit, right? It doesn't make sense to go beyond this. So for daily usage, 12 GB, 16 GB, 24 GB should be enough. But if you want to go beyond that, you should move to cloud versus you should not like upgrade your personal PC to like 64 GB GPU or something, right? You should not do that. So that's what I've done. I've kind of built a cheap PC. If I need more, I'll go to the cloud. Anyways, so I have this LLM now. So I create my LLM chain, which is prompt followed by my LLM, and then I do LLM chain dot invoke. Again, I provide the question. And it's the same question, by the way. Who is the CEO of Google and why he became the CEO of Google? Now, the thing is, this one is a Llama 3.2 1 billion instruct model. And look at the answer. It just gives you a one line answer. Larry Page. Explanation is the best answer is Larry Page. And first thing is it's incorrect. And it feels like super confident, right? Larry Page. So the problem here is that this 1 billion model is not that good, at least for this example. But I've shown you how easy it is to just download a model, use it. Of course, because of this example, I don't feel really good about this 1 billion model, but for many other cases, it might be useful. You might fine tune the 1 billion model for your own data set and things like that. And because of inference cost constraints and all, you might want to use 1 billion model. This is 8 billion model, but I guess a good trade-off would be like a 3 billion model with quantization. Anyways, so it depends on a lot of things. Next is I'm just showing you how to use a Google Gemini API. So I import google.generative AI as GenAI, and then I configure it with the keys from my config variable or object. Then I use Gemini 1.5 Flash model, which gives me a model, and I do model.generate content, and I give like a prompt or something. So I'm just saying write a poetry for beautiful sunshine. So I get a response. I can see the response.text and print it out, and you can see that there's a small poetry on beautiful sunshine. So this is all about text-based LLMs, but nowadays there's also like a lot of hype on multimodal LLMs, and I'll just spend like a couple of minutes showing you that as well. Okay, so this is the multimodal LLM Gemini notebook, which I've gotten from Google's tutorials. So again, I read the config.ini file and I load my Google API keys. And basically using the API, I also needs project ID and location and things like that. So I do that. And then you can also like import Vertex AI and you can initialize your project ID and location. After that, I could import generative model, image, and part. These things are needed to use the multimodal LLM. So I have multimodal LLM, two versions of it. One is multimodal model, which is Gemini 1.5 Pro, which is slightly expensive in terms of each API calls. And then you have this Gemini 1.5 Flash, which is slightly lightweight model. Anyways, we have these two models. Then we have a couple of helper functions. We don't want to go into it. We want to go into just the examples. So first example is, you can see there's a question. What is the average weather in Mountain View, CA, in the middle of May? And the prompt is, considering the weather, please provide some output suggestion. Give example for the daytime and evening. So I build my contents in a list where I append two things, question and prompt, one after the other. Then I call my multimodal model dot generate contents and I pass in my contents, which is question and prompt. Then I see the response. You can see that it kind of gives me a nice response. Mountain view weather in mid-May, enjoys pleasant sunny weather, expect temperature between this and this, sunshine, rainfall, outfits. It tells you something about that. So that's like one example where we are giving in text, which is like a normal LLM, obviously. Then you could also have document summarization. For example, there's a PDF for this Gemini 1.5 paper, which is like 77 pages. So we have it here in this location. Then we can read that PDF using this part object. So we get our PDF file. And then we have our prompt, which is how many tokens can the model process? Again, I create my contents by appending PDF file and prompt. And then I can use my multimodal model dot generate content. Again, I pass in my contents and I generate my response. And now you see that it's able to read the PDF and it's able to give me the answer up to at least 10 million tokens, right? It kind of takes it from the paper. Then you can also give a prompt like, you are a professional document summarization specialist. Please summarize the given document. And then again, you can pass in the content, which is PDF file and this prompt. And then you can generate the contents and you can see the response. It will give you some kind of summary of this paper in 4 bullet points. So this was more about processing PDFs or processing texts. Now comes multimodality. So here we have two images at these two locations. So I load those images from these URLs. Then I have a prompt, which is I have an oval face. Given my face shape, which glass would be more suitable? Explain how you reach this decision. Provide your recommendation based on my face shape. Please give an explanation for each. Right? And then I'm showing you the two images. I'm trying to understand which of these glasses will kind of match an oval face. Right? So again, I create my contents, which is just a list, prompt followed by the first image, followed by the second image. And then again, I generate my response by multimodal model.generate content, and I see my text response. So of course you can read this, but I'll not do that. But you'll see that it kind of gives you a nice summary. Oval faces is the most versatile for glasses because they're well balanced and things like that. And it tells you why you should use round glasses, why square glasses are less ideal, general tips for oval faces, and things like that, right? Experimentation, personal style, and things like that. So it is able to give you some suggestions, and if you read it, it kind of makes sense. The next one is generating video description. Again, the prompt is what is shown in this video? Where should I go to see it? What are the top 5 places in the world that look similar to this? Again, I can pass in the location of my video file. I can provide a type, which is video/MP4. And again, my content is prompt followed by the video. And then I do multimodal.generate content again, and I'll show you the response. So this is a video. It's a 30-second video. It's not much. It's kind of like a lighthouse, but an ocean or something, right? So that's the video. So again, you can see that it tells you where it is. It also provides like 5 locations which look similar to this where I can visit. And in fact, it is giving me the correct answer. Okay. Again, I have another video, which is Ottawa train. And then the prompt is which line is this? Where does it go? What are the stations/stops? Again, I read my video. I create my content, which is prompt followed by the video. I call multimodal.generate content. And then it gives me some output. And it tells you that this is a train line 2, which is in Ottawa and things like that. And in fact, it is, but it may not always be correct, but at least in this demo, we can see it makes sense. Then we have audio understanding. Again, you read the audio file. I'll not play it. It's a 10-minute audio file of Google Pixel as a product, some podcast around it. Now I can ask for summarization of, let's read the prompt. Please provide a short summary and title for the audio. Please provide chapter titles, be concise and short. No need to provide chapter summaries. Provide each of the chapters title in the numbered list. Do not make up any information that is not part of the audio, and do not be verbose. So that's my prompt. Again, I read my audio file. I create my content list, which is audio file followed by the prompt. I call my multimodal model.generate content again, and I see what is the response, and it gives me, like, for each chapter, it gives me a bullet points and things like that, how the audio is arranged, and it kind of makes sense also. You can also ask for a transcription based on this prompt. So can you transcribe this interview in the format of time code, speaker, caption? Use speaker A, speaker B, etc. to identify speaker. Please provide each piece of information on a separate bullet point. And again, I create my content, which is audio file followed by the prompt. I generate my content and I show you the response. And you can again see that it is kind of transcribing the audio. This one is kind of multimodal in a sense that this video has also an audio in it. It's a Google Pixel 8 ad. Again, I'll not play the whole of it, but this is the ad, right? So I have this video file which has also audio in it. Now my prompt is provide a description of the video. The description should also contain any important dialogue from the video. I read the video file, I create my contents list, I generate the contents, I show you the results. So it kind of gives you like a kind of a description of the video in short, and if any important dialogue was there and things like that, right? Here also I'm reading another behind the scenes pixel video, and it looks like this. It's like 5 minutes or something, and this demo is insane. So see, at around 50th second, you see this image, which is very similar to this. So here, there's a multimodal query. So I have a video file, then I have an image which looks like this. So I have a video file and image file, I've read it. And then I look at this prompt. Look through each frame in the video carefully and answer the questions only based on your answer strictly on what information is available in the video and things like that. Do not make up any information, not part in the video. Do not be too verbose and be straightforward. And then there are two questions. When is the moment in the image happening in the video? Provide us timestamp. What is the context of the moment and what does the narrator say about it? Again, we build a contents list, which is video file, image file, and the prompt, and I generate my response. And this is what here is the same thing, right? It is telling me the timestamp, which is 49 second in the video. And you can actually see that in 49 second, you get that frame. Okay. So it has gone through the video. It is telling you the timestamp where the image happened. It also kind of mentions that moment, what is happening, right? So this is an insane demo. The next one is even more insane, but yeah, we are doing multimodal LLMs, right? So this is like an e-commerce use case. Let's say the customer has this photo of a living room, and then it also has like photos of 4 artwork. And what I want is, I want to ask the LLM which of these artwork is the best for my living room, and provide explanation and things like that. The first thing is describe this room, which is just prompt followed by the room image. It describes the room. It gives you the description of the room. Minimalistic living space decorated in warm, earthy palettes, furniture, decor, overall impression. The next one is recommend a new piece of furniture for this room. Explain the reason in detail. So you have prompt 1 room image and prompt 2 again. It will give you some recommendations. And this last one is insane because we load those 4 artwork and then we create a prompt. You are an interior designer. For each piece of wall art, explain whether it would be appropriate for the style of the room. Rank each of the pieces according to how well it would be compatible in the room. And then you create your contents list. Consider the following art pieces: art 1, art image 1, art 2, art 3, art 4, and the room image and the prompt. So this is my content list. Again, I do generate contents again, and I'll show you the response. So this is my room image. I have these 4 artworks, and then it has ranked the 4 artworks. It is saying the best one is art number 2, then 1, then 3, and then 4. 2, then 1, then 3, then 4, which also makes sense, right? 4 is the most unlikely image for the room. The second one is the best. First and second, still you might be confused based on your personal preferences. But at the least 3 and 4 feels like it's not that aligned to the room. And then it gives you like nice explanations of why it is choosing things. For example, R2 highly suitable. Explanation here is this minimalist botanical print aligns perfectly with the room's existing aesthetic. The neural palette, organic shapes and simple composition complements the natural materials and warm earthy tones and things like that. So this was all about like using multimodal LLMs, which is provided by Google Gemini. And that was all about LLMs, what it can do for you. Let's go back to our things, right? So we have seen what LLMs are and what it can achieve. It feels like it is a single step process, right? You provide a prompt, it gives a response. You provide a prompt, it gives a response. You provide a prompt, it gives a response. It's like a single step process. Now, there are many LLM applications which use control flows. So, for example, we could have like a starting position, then we would have like step one, then we have LLM, then we have a sequence of steps. We have step number n, and then we have an end. Right? So basically, this is the LLM call, but we'll have like pre-LLM call steps, couple of them, post-LLM call steps, couple of them, and then the chain ends, right? So this is an example of chain where we might want to do like a tool call. What it means is, let's say my prompt is in such a way that I wanted to do a calculation. So I might have like a function for various things like addition, subtraction, multiplication, division, and things like that, right? I could have like a couple of functions. I could attach these functions to the LLM, which is called like attaching tools to the LLM. And LLM can fill in these functions or the input to the functions from the prompt. And this function will return you some answer, and the LLM will process what it returns and give you a nice answer. That's the tool calling example. Another example of this sequence of things could be for retrieval. So again, I'll give you like a couple of examples of these things. But the idea is that this kind of control flow where like you have a start step and then you have a step one, then you let's say I have an LLM, then you have some sequence of steps, then you have step n followed by end state, right? And this part, right? So this is like a deterministic control flow where while programming this flow itself, we know what are the steps which will happen. LLM is just like the brain, which kind of takes in the step one and gives you some response, and then you can post process and things like that. So this sequence of things, which has an LLM in it, is called like a chain flow. So LangChain is something which allows you to do it, right? And chains are in some sense reliable because it does the same steps again and again because you have programmed it that way. So if you call this thing again and again and again, it just follows the same sequence of steps again and again and again. So this is an example of a chain. And one of the best application of these chains are something called RAG, which is retrieval augmented generation. Maybe you have heard about it, maybe not. I'll just briefly mention a couple of things about it. First thing is like most of this world's data is private and we can feed it to LLMs, right? Because in the end, if you're just generating your responses from an LLM based on just the parameters of LLM, there's only so much LLMs can memorize or what it can process in a certain way. And if the data is private, there's no way the LLMs have been trained in private data, right? So think of LLMs like a CPU and RAG as like attaching some storage to your CPU. Think of it that way. So let's say at the center, you have like a LLM, which is like a CPU. And then this LLM could interact with certain things. For example, it could interact with tools. I gave you a calculator example, but it could be other tools like location, weather, whatever. Then it could also interact with input-output devices, audio, video. It could also interact with search tools, which is in a way internet. It could interact with other LLMs, and it might have its own data storage, and it might want to interact with its own data storage to kind of build a context around which it will generate the response. Okay. So, simply put, what is retrieval augmented generation is, let's say you have a question or a query, and like let's say you have a lot of private data, So you kind of pre-index all your data. So you have all these document one, document two, and so on. You index all this document into some kind of a database. I'll call it an index because I'm doing indexing. So this is my indexing step, which I do it offline or while I use it. It depends, but usually offline because I might have like hundreds of thousands of documents. Then based on the context and my index, I might want to retrieve relevant documents, which I'm calling the retrieval stage, right? Now, once I have my relevant documents, I might want to feed in the relevant documents and the question into my LLM, which in the end needs some context for generation. So this is called like the generation phase. An LLM finally spits us a response. If it's a question, usually response is like an answer, right? So this is like the basic flow of RAG, which is retrieval augmented generation, which means that I'm kind of augmenting retrieved documents into our LLM context to get a response from our private data or something like that, or whatever data, right? And if you look at this, it's kind of like a flow, right? You have this question, you have this retrieval, you have this generation, which is like a couple of step process, which looks like our chain, right? I showed you that, right? You have step one, then you have step two, which is the retrieval, then you have an LLM, and then you have a response, which is step three. And then there's an end, there's a start. So you can see that RAG, which is retrieval augmented generation, allows us to add some kind of memory to our LLM. For example, if I have some private data or legal data, let's say I'm a law firm and I have like a lot of legal data, which I index it, and I might give this LLM some legal questions, and it might want to give me a response based on my private data, right? So this RAG allows me to attach additional data to my LLM. So you can see what a chain is in some sense, right? And of course, I mean, RAGs could be very complicated. I'll just uh, give you a super high level thing. So there could be like a question phase, and then there could be like a query translation phase, which kind of takes in this question and it rephrases, decomposes the question into multiple steps. It takes a step back, it generates a higher level question, it breaks down the question into smaller questions. So this question is broken down into maybe multiple queries. It depends, but there's a query translation step. Then there could be like a query construction step where, so for example, I might have my data stored in various databases. It could be a vector store. It could be like a relational DB. It could be maybe even graph DB, right? So I have some text here based on my question, and I want to do queries. So vector search is easy. You just embed your queries, which is text, into a vector space, and then you do a vector search, which is fine. But if you want to do the relational database kind of a thing, you want something like text to SQL, which itself is a big problem, but it's kind of doable. You might have some kind of a querying system for graph DBs. So you might want to convert text to that form. And there's something called a cipher query language for graph DBs. But anyways, like the point is we might want to convert this modified query, which is through query translation, to get some form of things which can be supplied to these vector stores. And each of them will give me some documents. And then I'll have like collection of documents here, which is this my relevant docs, right? Relevant docs. Once you have your relevant docs, hopefully, after that, you might want to re-rank your documents here. So you might have like a re-ranking phase, which is again kind of a funnel in some sense where re-ranking is kind of bringing up the relevance of the document because all these DBs are just giving you like a lot of documents, which is kind of like a high recall system. You don't want to miss out on things. But maybe there's too much information here, which is also some of them might be irrelevant. So we want to have like a relevance stage, which is the re-ranking stage, or some refinement stage also, whatever. So in some sense, I'll take this all these relevant documents, hopefully relevant, but I pass it through the re-ranking and relevance stage so that I get some kind of filtered version of these documents, right? Now, once I have this filtered set of documents or summary of filtered set of documents, I can again pass it to my LLM, which will generate me in the final response, right? So this is like my complicated RAG pipeline, which can be there. But what you will see is that for any question, we are running the same pipeline again and again and again. So it doesn't matter what we are giving as input, it will run the same pipeline again and again. So in some sense, this RAG kind of thing or a LangChain kind of a thing has a fixed set of steps to accomplish a task, which is kind of hard coded in some sense, right? But what we want here, so we have seen what a chain is, right? And we have seen an example which is a RAG, is an example of chain, and there's a library called LangChain, which allows you to implement this chain or this retrieval augmented generation pipeline, which is like a sequence of n steps every time, whatever be the case. Now, what we want is we have this start state, we have this end state, and then our dream is that we'll have an LLM which kind of decides a sequence of steps. Step one, step two, step n. So this LLM is like doing a lot of stuff in itself, and it kind of comes up with sequence of n steps to do to accomplish a task. And because of that, this sequence of n steps can change for every query because LLM is deciding what to do, how to break down a certain task into sequence of steps and things like that. So in terms of invocation, what might happen is for a certain input, you might just have two steps. Step one followed by step two. Maybe for some other situation, I might have like step two followed by step one, followed by step one. Because let's say I have like all possibilities of steps we should do, but we don't know the ordering of steps or what steps we should select for our task. And LLM is kind of deciding on it. So maybe for a certain input, it decided that S1 should be followed by S2. For some other input, it decided that S2 should be followed by S1, should be followed by step S1 again. And it could be again S1 followed by S1, followed by a certain lot of stuff, followed by step N. So in some sense, I have like a collection of steps which can help me accomplish any task. Even each step could be certain tool call, maybe search query call, maybe a RAG call, whatever, right? But we have this collection of steps, and LLM is kind of deciding what is the collection of steps I should do in order to accomplish my task. So an example of that could be a control flow. For let's say maybe I have like a start state, then I have my step one, then we feed it into an LLM. Now LLM kind of decides whether we should go to step two or step three, and then wherever we go, we end after that. So in some sense, again, like still my graph is kind of fixed, but the flow of control here is not fixed. LLM is deciding whether we should go via this path or we should go via this path, right? So in some sense, LLM is the brain of this graph, which is allowing a certain part to be activated based on the inputs. And that's the contrast with a chain, right? So this is an example of, let's say, a simple agentic system where LLM is the brain, right? And we also saw the chain kind of a thing where we have a start state, then we have a sequence of steps, and then we have an end state. Step one, step two, step three. So this is an example of a chain where independent of what is the input, we follow the sequence of hard-coded steps every time. But in terms of agentic systems, which path will be followed is based on the inputs. So in some sense, it is LLM defined control flow, which is kind of a simplest agentic system. Okay. Now the thing is there could be many, many kinds of agentic system. For example, the one I showed you, right, where I had step one followed by an LLM, and then the LLM decides whether I should go to step two or step three. And after that, we will end whatever it is, right? So here, it's like kind of a simple kind of an agent, which is called a router, where LLM is deciding where to route the flow, right? But I could also have like a fully autonomous agent, and the fully autonomous agent is like an LLM sitting in the middle, and I have my start state, I have my end state, and in some sense, I have state one up to state n. And the LLM is deciding on the sequence of states to follow in order to have like a full autonomy in terms of agentic systems. So in terms of control, you'll see that in this router example, I have less control. In this fully autonomous kind of a setup, I have like high control. So LLM is in high control here because LLM is kind of deciding the sequence of steps to do in order to accomplish a task. But in a router, it's kind of fixed that whether step two will be done or step three. LLM is just choosing between the two. So the control is less, but then in a lot of cases, that is what is important. But it's also about reliability. For example, let's say this is for the control, right? Here we have less control, here we have high control in terms of LLM doing something. But in terms of reliability, it might be something like this, that this simple router is more reliable and this fully autonomous system is less reliable because LLM is deciding on the steps and things like that. So in some sense, we are allowing the agent to do whatever it wants to do, right? And in terms of flexibility of our flow also, this router kind of example is an example of low flexibility or low agency. And in this fully autonomous kind of an example, we have very high flexibility or agency. So I hope you kind of get the idea of what we can do. But obviously, we need some kind of balance. This router is very limited in terms of what it can do, but it is very reliable. This fully autonomous kind of a thing can do a lot of things. It's very flexible, but reliability might go down. And there could be a range of tasks in the middle also, which is somewhere in between router and fully autonomous agents. And the goal is to kind of balance reliability with control. Okay. In fact, we could also do cyclical things. For example, you might have a start state, then you might have a step one, then you might have an LLM. And LLM might decide that we should go to step two, or LLM might decide that we can go back to step one and reiterate. So this could be an example of a self-improving system where we're kind of continuously improving the input to the LLM so that it kind of does a task better. And LLM is kind of in control. So if you think about agentic system in general, like basically LLM is the brain of the agentic system, and you could have multiple LLMs in the system. But at least what we have discussed in this video is a single LLM as a brain and it decides the flow. But it could also be called multiple times. But yeah, I mean, I'll show you one more example, which is slightly more complicated. But the idea is that in the end, we have some kind of a graph of potential paths, and kind of LLM is deciding which path to choose in some sense. And there could be cycles in the path as well. And to easily implement all these kind of complicated structures for your particular like application. So what we have done is basically we have gone from a chain to a graph, and the libraries is more like in chain we have like lang chain, and in graphs we have kind of like something called a lang graph. So these are the libraries you might want to use at least in order to learn what you want to do. But once you learn, obviously you are free to implement. You might not want to use any library. You might want to build it from scratch and things like that. But in the end, we have a library called LangGraph, which can help you build complicated graphs and control flows, and control flows are decided by LLMs. So here is an example of agentic AI system. And the goal is kind of like building a research assistant. So the goal is to build an AI-based research and report generation assistant. So here the flow is something like this, like we provide a topic, and then we kind of create a set of analysts that will research the subtopics. And there's a human feedback which can happen to refine the subtopics. So in some sense, what is happening is we kind of provide a topic, and the system generates a team of AI analysts, each focusing on one of the subtopics. That's this stage. And we have human in the loop kind of a thing to refine these subtopics before the research begins. Okay. Now, once you have these analysts, then each analyst will conduct an in-depth interview with an expert AI using the selected sources. And the interview is kind of like a multi-turn conversation to extract detailed insights. There's a paper for this idea, but let's not go there right now. So once the interview process kind of happens, the expert will gather information to answer the analyst questions, and then we kind of gather all these interviews and build a report out of it. So that's the high level idea. Okay. So the first step here is to create analyst persona. So we have a module called create analyst, and then it goes to human feedback. It kind of cycles around a bit. And in the end, what you'll get is multiple analysts. So I'll give you an example so that you understand this step. So let's say I want to create three analysts. So obviously I need to know I want to create three analysts. Then I need to choose a topic. For example, a topic is the benefits of adopting LangGraph as an agentic framework. Let's say this is the topic. So the topic is the benefits of adopting LangGraph as an agentic framework. That's the topic. So now what we might want to do is like we might want to create three analysts. Maybe the first one is AI framework specialist, and some description of the specialist. Maybe one role could be like ethical AI advocate, and the third one might be like business strategy consultant, and description of each one of them, obviously. So let's say we have these three analysts, and we might want to like refine this with human feedback and things like that, and then eventually you'll get some collection of analysts. Next is we kind of borrow a tool, some kind of a search tool. Let's say Google search or DuckDuckGo or Tavily. So all these are like search tools. If you provide a search query, they give you some results. And then what you do is based on the LLM, you kind of take each of these analysts and LLM will generate like questions for your topic, and it will feed in that question to the search tool, and then that will return you some data. And it does that exercise either to search the web or search Wikipedia or whatever. But the idea is that LLM kind of generates question, it will search, and it will kind of collect all the information for each of the analysts. So this is what it looks like. So kind of ask the question. We can do a like web search. We can do Wikipedia search. We kind of answer the question, and we can go back again and do the same exercise optionally. This dotted line, because it's an optionally, you can go back. And then once you have like a list of answers to the question, you basically have question answer pairs, right? So you can save the interview and you can write a section based on this. And this is kind of like for one analyst, right? Now we can kind of abstract this out. Now what we just saw is like conducting interview, right? Now basically we see everything together. We have start state, then we create analysts, and based on human feedback we can modify our analyst. But once we are done till this point, we have all our analysts. Let's say 3 to 5 analysts we have based on different expertise. Then again we start conducting interviews in parallel for each of these analysts. So again, for each of the interview we have a start, we ask the question, because each analyst can generate questions based on the topic. We can search the web, we can search Wikipedia, we can get answers, we can go back also optionally. We save the interviews, we can write the summary section for this interview. And for each of the analysts, we do this exercise. So we have like a lot of, for each analyst, we have like a summary. Then we might have these modules like write introduction, write conclusion, write a report, and then finalize the report. So this is what is like a research assistant, which kind of can automate research process by browsing the internet, right? So I know this is all very complicated, but I just wanted to give an example of how complicated the agentic systems could be. Now, these agentic AI systems could have like various options. For example, it could be like chatbots, where you're trying to build like a customer support kind of a chatbot or code assistant. So let's say if I have chatbots, you could have like customer support. You can build like a code assistant. You could also have like another category of problems like RAG systems, retrieval augmented generation systems. So you could have like an agentic RAG, and we can use an agent to figure out how to retrieve the most relevant information before using the retrieved information to answer the user's question. There's something called an adaptive RAG, which kind of unites two things. One is query analysis, and second is self-corrective actions on the RAG. Now, there's something called corrective RAG, which uses an LLM to grade the quality of the retrieved information from a given source. And if the quality is low, it will try to retrieve the information from another source. There's something called self-RAG, which is kind of it tries to incorporate like self-reflection or self-grading on the retrieved documents and generation. I mean, of course, it's very difficult to go into each one of these. Maybe once in a while, I can dive deep into each one of these as a separate video. And you could also have like something like SQL agents as well. Even in terms of agentic architectures, we can have a multi-agent system. We could have like a planning agent, and we can have a reflection and critique. And we have also seen experimental agent just now, right? It was like a web research assistant or something, right? So anyways, like these are like the kind of agentic things you could do. And there is a lot, by the way. In the end, it's a very general tool which can take the help of an LLM to decide on a sequence of things to do to accomplish a task. And that's the main idea of agentic system. And as an example, we just saw this example, right? Which was like a research assistant agent, right? So it could be very complicated. And these control flows are decided by LLMs. For example, here you ask questions, it searches the web and gets some answers. But you could refine the question again based on whether the LLM is not satisfied with this answer. It can refine the question and go back to ask question again, and it can do a couple of times. So in some sense, it is not a hard-coded flow. Here also, the human feedback is not the hard-coded. So based on human feedback, it goes back again and again and again. So in some sense, the control flow is decided by an LLM, and that's kind of an agentic system in some sense. Okay. So I hope this kind of gives you a very good idea of agentic AI. And of course, I feel like I have been very abstract, but I feel like this kind of gives you a big picture of everything. We first saw what an LLM can do, which is a single step operation. And then we looked at what we can do by hard coding a chain of events and accomplish something. For example, RAG, retrieval augmented generation. We also looked at how LLM can be used to decide on a control flow for a particular input, not for a particular application. It's not hard coded. Based on the input, LLM decides what needs to be done. And that's agentic here, right? So anyways, that's the very high level idea of agentic AI. But under all these examples, if you just focus on this research assistant, it is kind of an AI assistant which can act automatically to achieve a goal without constant human guidance, right? And in some sense, that is what agentic AI is. It has some kind of automation inbuilt in it, and it can do things automatically with least amount of guidance. So to summarize, agentic AI is like a kind of like a paradigm which uses sophisticated reasoning and iterative planning to autonomously solve a complex multi-step problem. And it could enhance productivity and operations across many applications because it's kind of almost like an automated system. So that's what agentic AI is.